This video is all about loops. I've been all over the internet to bring you the best video I can on this topic. I'll go into that and what I did to achieve this little animation, as well as what you can do to create your own. Real quick, if you're new here, my name is Robert Shane, and on this channel, I give solutions to tech problems, how-to videos, and tutorials. With that out of the way, let's get into it. The bulk of this video will cover how animated loops are made in general. I'll discuss a little bit about how I made mine. However, I won't go into every little detail like I do in most of my videos. This tutorial is designed to get you to think creatively about how you could approach this problem. I will be sharing the scene file so you can have a look at it if you want. It can be downloaded for free, link in the description as always. Before you begin creating, I think it's a good idea to step back and look at what has already been done. I assume you've already seen some examples, and that's why you're here, because you want to make your own. But as you look through them, you should be thinking about what you can do differently. Don't just repeat what has already been done. For mine, I was really inspired by this piece called Star by Arbin. I've seen this motion before and I thought I could recreate it. I've changed it up a bit by rotating the base counter to the top spinny bit, so it's doing something different, and that's how you should be thinking when you're looking at other people's work. What can you add to it? What can you change? What can be made more complex or simplified? Maybe a piece will inspire you to make something completely new. Now that you have your idea, how are you going to implement it? If we look at some examples, you'll notice things either translate, rotate, or scale, but they always end up back to where they started. Any movement you do, whether it's a ball bouncing, a background translating, or some cylinder scaling, all have to start and stop at the same spot. So now the question becomes, how do we get it back to the same spot? Well, my friends, that depends. Say we have a background like this. We could literally move it in any direction we want, figure eights, circles, random, as long as it comes back to the same spot. Since we're working with motion, it has to be moving in the same direction and at the same speed, but that's getting a little ahead of ourselves. But for your first one, you're probably going to want to keep it simple. Over time, you'll find ways of making things more complicated. However, I think a more interesting approach here would be to have the background use a tessellating pattern, and then you can move it by the distance of the tessellation. This could be something as simple as a grid, or as complex as an MCS tessellation, although that might include some rotating as well. However, rotations are pretty straightforward, and I think they are the easiest to understand. As long as something rotates once per loop, then you're good to go. It can get a little more complicated though when you consider symmetry, and lots of things can be rotated. Don't just think physical objects either. Textures can rotate, which is really good as they can be animated seamlessly even if they don't tessellate via translation seamlessly. They'll always be seamless via a rotation, and that can be used to drive everything from color to having things move via a height map, which is what I did in my previous two videos. The next on the agenda is scaling animations. These are the hardest to wrap my head around, and I think they are by far the most interesting to watch because of their complexity. I had to reach out to a few people online to even understand it. The gist of it is, as long as objects look the same when they're big as when they're small, or vice versa, then they'll loop. Now, I know this probably doesn't make a whole lot of sense, so let's take a look at this wonderful example again by Arbin. He actually collaborated with another 3D artist who gives a much more in-depth look on how this exact piece was made. A link to it is in the description. You have these cubes that scale up, and if we scale them up by a certain factor, it looks the same as when it's small because these smaller cubes were scaled down by that factor. So we're just undoing what was done. Each one of these cubes have been scaled by a certain factor, and when you scale them all up, the whole thing looks the same. And it's at this point in the script that I'm actually back from a 2-week rabbit hole where I was trying to understand the math behind these scaling animations, because there's actually a lot of things to unpack with them, and I think I have a lot of useful information, but I'm still trying to tie up some loose ends. It's detailed enough that it deserves its own video at this point, and I really don't want to bury it in the middle of this video, so subscribe if you don't want to miss that. It's also possible to combine two or more of these things. For example, say we have two random objects. We could spin one 360 degrees per loop, and the other translate off screen and reappear on the other side. That would still make a seamless animation. If the rotating object has rotational symmetry, then we could go even slower. And all this complexity leads me to my next point, which is math. Some of these animations are really math heavy, but it sometimes depends on how accurate you want to make the animation. Some math you can avoid, like how to make something with, say, 3 and 5-fold symmetry rotate as slow as possible. They have to be exact and there's no getting around it, or else they won't loop seamlessly. Sometimes you might want to make something physically accurate, so be prepared to work out some math, animation is multidisciplinary. Don't be afraid to watch a video on how to make a pendulum swing if that's something you want accurate. You might not have to know all the math, but it helps to know the rules before you start breaking them. But also don't forget that animation is art, and as long as it's close enough, it can be good enough. In the arts, if it looks good, it is good. Don't be afraid to try something new either. For my first piece, I tried an odd number of balls, only to realize later that it wouldn't work how I wanted it and thought it was a total loss. But then I realized if I had some obstacles come up at the right moment, they could make the balls bounce in the right direction. So not all was lost, and I ended up with something that someone else might have written off as impossible. And one final bit I wanted to add is once you have your animation, it's all rendered out, another important thing to consider is sound design. For mine, I used an electric motor for the base spinning, and this whooshing sound for the ball sliding. I'm not a sound designer, and this is getting a little outside of the scope of an animator. I found these sounds free online. Starting out, you'll have to do sound design on your own, but if you get big enough, you can find a sound designer or a musician to collaborate with and make some epic stuff. If this was useful, please consider subscribing. I hope you learned something. Bye for now.